Hello. You guys are going to be working in this forest on English Tern. And so this talk I have entitled The English Tern Forest, Their Composition and Significance in Post-Katrina New Orleans.
It's a great title.
Hit it. Hold on a sec. Dang it. All right, so here's beautiful Louisiana. Hit it. Hit it.
I mean, already hit. We've already arrowed.
Oh, you did? Okay, good. Sorry. Oh, I'm supposed to hit it. That's New Orleans down there. Hit it again. This is Shreveport. The only reason I mention that is that's where my wife is from. Shreveport.
Oh.
Yes, that's Shreveport, Bossier City. And hit it again. And there's English Tern. Actually, the only reason I mentioned Shreveport, you see how high Shreveport is up there. That's about 500 miles from New Orleans. But it's about 1 million miles from New Orleans culturally and politically. This is a very conservative. Actually, New Orleans is kind of an island of culture in a sea of very
different
very,
culture.
Very different cultured. The rest of Louisiana is very different cultured. Hit it.
Yeah.
And that little elbow there is English Tern. Hit it. Okay, you sort of
I'm
following me?
just watching it.
Okay, good, good. So here's New Orleans with Lake Pontchartrain to the north, and that's up above, and to the east, to the right is Lake Bourne, and you can see the city. You can see the Mississippi snaking through the city. There's English Tern, that knob, that little peninsula caused by this big turn in the Mississippi. Here's a close-up of English Tern. English Tern has some very nice large fragments of bottomland hardwood forest. That's the forest type that's characteristic of the area and the Mississippi floodplain and the Gulf Coast, most of the Gulf Coast states. Less than 20% of these forests are still intact. And old growth examples of bottomland hardwood forests are now very, very rare. The forests in New Orleans area are largely gone and are continuing to disappear. For example, this I shot in August 2015. It's almost a square kilometer of forest cleared for development. That's definitely not a good thing for New Orleans. These forests provide New Orleans with a number of ecosystem services, one of which is the ability to buffer the city from the effects of hurricanes, both wind and surge. And as you likely know, sea level and the frequency of hurricanes is projected to rise significantly in the next century. So cutting down forests is not a good thing. This is John in an English Tern forest after a rain. That's about 2 feet of rain he's standing in. And that's the beauty of these forests. They behave like sponges. They soak up flood water that would normally flow into canals and populated areas. Here's a student, and when it rains in New Orleans, and it does that a lot, these forests hold rainwater and slowly release it over several days, which reduces the intensity of flooding. This is a CSUCI student making forest quadrats in a flooded forest. And if it doesn't rain, this forest will be dry in 3 or 4 days. Not only do these forests contribute to flood protection, they also support all kinds of wildlife, including tens of thousands of migrating birds like this hooded warbler, which they were banding at Delacroix when I shot this. But despite their beauty and diversity and the worsening situation vis-a-vis rising sea levels and increased hurricane frequency, bottomland hardwood forests are still being cleared. This is a paper published in 2002 by White and Skojak. In it, they do a floristic surveys of 7 of the most intact, pristine bottomland hardwood forest fragments left in the New Orleans area. Here's a better picture of the map. The letters correspond to the forests: Airline, Hermit, Jackson, Lafitte, Oak, Sauvage, and Verret. Next, Sean. Here's English Tern right there. Now, English Tern was not included in this paper for reasons I'll talk about in a bit. Here's the sad part. Between the times White and Skojak wrote the paper, sent it out to be reviewed, and they published it, two of the forests, Airline and Verret, had already been cut and cleared for development. And it looks like Sauvage was more or less destroyed by Hurricane Katrina. And this is kind of interesting. This is how it happened. This is Biosauvage National Wildlife Refuge on August 16th, 2005, 13 days before Hurricane Katrina made landfall on the 29th. I'm going to zoom in on that little square now. Those are tree canopies that are more or less continuous. Now, this is Biosauvage on September 7th, 8 days after the storm. The whole forest is underwater. Whole forest is underwater. Salty water from a huge canal called the Mississippi River Gulf Outlet. They call it, for short, they call it Mr. Go. Here's a closer view. Look at that. You can't even see the trees. That's water completely covering the forest. Those white marks are like waves. The salty water was trapped. Here's the weird thing. The salty water, they wanted to protect this forest, so they built levees around it. This salt water was trapped for 4 weeks by these levees that were made to protect the forest surrounding the refuge. It took them 4 weeks to pump the water out. And this is Biosauvage 5 months later in February 2006. Here's a closer look at that. You can see that the forest is completely trashed. The trees are down and defoliated. There's not a piece of green in the whole patch. And this is 2014. 9 years later, you can see this huge brown spot. The forest is still trashed because of salt water. When it evaporates, it leaves more salt. English Tern fared much better. There are many trees left standing, and there doesn't appear to have been saltwater flooding. So the vegetation grew back fairly quickly and continues to regrow. So the trees were denuded of leaves, but they resprouted. They created more leaves. They weren't totally killed. But the forest has been heavily impacted by development. Here's a golf course. Here's a little community right there. There's suburban encroachment along the edge there. That's where... Whoa. That's where... Got nervous. That's where Katie lives. I'd say over 50% of the English Tern forest has been developed or degraded in some way.
And real quick, I'll just note that right here, you guys, this is Orleans Parish. Outside here, over here is Plaquemines Parish. So we're right on the edge of what we would call the city of New Orleans and the lower, more rural parish.
So 50% of the English Tern has been developed or degraded. The good news is there's still 50% that has not been degraded and is still more or less intact in these 3 big patches.
Half full, glass half full, dude.
And these patches are almost continuous, which has significance in animal dispersal and such. So together, they're a relatively big chunk of forest and a good target for conservation efforts. In fact, 2 large patches are currently being managed as reserves by Katie Bracet, our collaborator. They're Woodland Trails and Delacroix. This is where you guys are going to be working. In 2014, we set up some plots in Delacroix. That's the one on the right. And that's what I'm going to show you now. Here's a closer view of Delacroix. And those are 8 plots. They're 20 by 20 meter plots. This is a list of the tree species we collected at Woodland and Delacroix. All of these have herbarium specimens, so they're documented. We collected 30 species in 22 genera in 17 families. This is the data from the 8 plots we did at Delacroix. These are in order of abundance, or essentially density. Trying to characterize a forest using abundance or density can be misleading because a lot of small individuals can look more important than a few really large individuals. So foresters have come up with this other measure, which they call importance value. Species importance value is a combination of a species' relative density plus its relative basal area. And basal area is just the cross-sectional area of a tree at breast height. Very easy to calculate. These are importance values from Delacroix on the left. In yellow, up there it says Delacroix. That column is Delacroix. And the rest of the columns are from White and Skojak's forests. And they do not include Delacroix. And then on the very far right are the mean importance values from White and Skojak. So we can compare Delacroix and the means from the White and Skojak forest. Delacroix differs from these other forests in some significant ways. First, the top two species in the White and Skojak forests, Quercus virginiana, which you can see on the back table, and Celtis levigata, aren't even present in the plots at Delacroix. This was kind of surprising. Acer rubrum, red maple, is the dominant species in our plots at Delacroix, but it's only fifth in the White and Skojak forests. Our second dominant, Taxodium disticum, bald cypress, is a tiny component of the White and Skojak forest. And bald cypress is really a huge and majestic tree that's important economically and culturally in the area. Hugely important. And ecologically, yeah. Cypress is a gymnosperm. It's a conifer. All the other trees are angiosperms, flowering trees. And our third dominant Delacroix, fraxinus, those are the ashes, is generally a marginal component of the White and Skojak forest. So it really does look like Delacroix is very different floristically from the seven forests that White and Skojak surveyed. And I think the reason has to do with the history of land use and hydrological modification in the English Tern Peninsula. So these are the English Tern forests today. It's mature bottomland hardwood forest with a more or less closed canopy between 25 and 40 meters high, but it wasn't always like that. This is a map of English Tern published in 1803. It's hanging on the wall of a museum in the French Quarter called the Historic New Orleans Collection.
Where we will go.
When this map, what this map shows is that the original vegetation of English Tern was stratified with forest along that inside edge of the Mississippi. So there's forest all over here. Yeah, right here. Forest all over here. And then marsh over here. And it looks like the forest has been more or less cleared around the edges where these long, what I believe are canals.
And I'll just make it a quick note that everything in Louisiana was relative to the river. So you guys are used to people cutting up property in squares, like when we have farms. Here, everything is relative to the river. So especially the original property, you had to have access to the river. So everything is long, more linear parcels, right? So it's more important to have narrow, but yet have access to the water than it would be to have a big, more typical square type of patch. So that's why the property, and you'll see this in many things when you look through different images, it looks that way.
So it looks like, as you can see, in the forest near the Mississippi has been partially cleared, and there's this interior labeled prairie, which is likely a wetland dominated by grasses, a marsh, something like this, which is a marsh about 8 miles east of English Tern. Beautiful picture of that.
Wow, who took that picture? Artist.
So this is the kind of vegetation which is created by levees. Levees are ridges along riverbanks. They can occur naturally, or they can be built to contain a river or a canal during flood stage. This is Steve Nelson explaining how that levee back there, you can see that concrete wall, how that levee broke during Katrina. It's an artificial levee with a concrete flood wall on top. This is also an artificial levee, but it's built to contain the Donner Canal that drains English Tern today. Levees can also form naturally, of course. This is the initial condition. A river with its banks at seasonally low water levels, when it's not raining and perhaps it's hot. Here's the river at flood stage. At flood stage, the largest, heaviest soil particles suspended in the flood waters get deposited closest to the river. And the lighter, smaller soil particles are deposited further away. After many floods, natural levees along the river form along the riverbank, with soil elevation higher along the riverbank and decreasing as you move away from it. The soils at higher elevations drain toward lower elevations where water accumulates. This gradient in soil water affects the distribution of plants. Plants that can tolerate a lot of soil water, like marsh grasses, grow there on the interior. And plants that require drier conditions, like trees, grow on the elevated levee. And this is what you see represented on this 210-year-old map. Water is draining away from the Mississippi, perpendicular to the river's natural levee, and accumulating in these wetlands, and then flowing south in this major bayou. And the plants are distributed, as you'd expect, across the soil moisture gradient, with trees on the elevated levee along the Mississippi and larger bayous, and wetland grasses in the lower elevation soggy interior. These double lines appear to be drainage canals intended to drain water off of cleared areas for cultivation and habitation, horticulture. These same methods are still used today to drain and dry land. This area is Delacroix, and above it is this suburban development. That's where Katie lives. Remember, water, in this case rainfall, flows perpendicular to the levees in this direction. Here you can see how the developers of these properties have dug a series of small canals to drain the properties into this larger canal below. Here's the larger canal. It flows into this golf course, and where it becomes a part of the architectural detail of the golf course. It flows through the golf course, and then flows out of the golf course here, up there, and then it's pumped, goes into this canal, and it's pumped into the intercoastal canal here at this massive pumping station that can pump tens of millions of gallons of water a day. What this means is that all the water flowing out of the development, which would normally accumulate in the center of the peninsula, is being pumped into the river. Here we are back in 1803. This is 90 years later. This is a U.S. Geological Survey topographical map from 1892. The canals are still present, those little canals going away from the Mississippi. But it looks like the forest belt has been entirely cleared for cultivation. While the forest appears to be gone, the interior marsh is still present. Now here we are 40 years after that. This is another USGS map from 1935, and it looks like the English Turn marshes are now entirely gone. And here's how they did it. They built 3 serious canals: the Norman Canal, the Donner Canal, and the Planters Canal. Katie Bracehead, one of our collaborators, which you'll meet, believes English Turn was drained for 2 reasons: agriculture and yellow fever. New Orleans had been plagued by major yellow fever epidemics in the 19th century. And yellow fever is transmitted by Aedes aegypti. Mosquitoes require standing water in their larval stage, and so we think that English Turn Marsh was drained in part to prevent the scourge of yellow fever. This mosquito is kind of a metaphor for what we did to English Turn. We sucked the marsh dry. So in place of the marsh, we now have a forest. It may not be pristine, naturally occurring forest like the forest White and Skojak surveyed in 2002. But the good news is that it's beautiful, supports lots of wildlife, and actually does a better job of protecting New Orleans from hurricanes than a marsh. because it's taller, it can hold more water. Despite these important functions, the English fir forests are constantly under threat, most recently from a proposal to build a baseball facility. Without massive intervention, the prognosis for New Orleans at the end of this century is kind of grim. Saving a growing forest seems to me to be a cost-effective way to protect New Orleans from the inevitable Cat 3, 4, or 5 spitting out of the Gulf of Mexico. Forests are important, especially in New Orleans. We need to preserve as much forest as possible, as fast as possible, and we need to grow more if possible. There's a lot of, you'll see when you get there, there's a lot of land around New Orleans that seems to be being used for marginal farming, or it's just gone to seed. And that kind of land could be used for growing more forests. That is the end of my talk. And now, John, would you like to talk a little bit about your...
Well, I have a question, actually.
Oh, yeah, shoot.
Question.
So,
Let me go back.
how would you, in terms of the species composition of this forest, what would you say, like if I'm going to ask you what type of forest this is. And you said it's a bottomland hardwood forest, but it's
Yes.
not really like
Well,
the other bottomland hardwood forests you
No.
showed us.
Well, bottomland hardwood forests come in many, many, many different flavors, and these flavors are determined by the composition of the trees. And whether a tree is present in one of these forests depends on the hydrology of the area. Some of these trees can grow in water for a long time, not continuously. Maybe Taxodium disticum can, but most trees cannot grow in totally flooded conditions. And there's this continuum of tolerance for water in the maybe 100 possible bottomland hardwood species that can grow in a spot. So the drier it gets, you get a certain community there, and as it gets wetter, the species change until you get another kind of forest at the other end of the continuum, the wet end of the continuum. Does that make sense? And it's the forested English tern are kind of weird because it seems to have some it's like it has a hangover from its wet period. There are some trees there like Taxodium disticum that appear to have been here for a long time and be a holdover from a wetter period. Now the peninsula has been drained, and so you get a lot of trees that like drier conditions mixed with the trees that like wetter conditions that have been able to hang on because their natural lifespans are hundreds of years.
But this is like many areas in the world, right? The notion of pristine doesn't really probably exist anywhere. And so we have this new series of stressors, right? New series of environmental conditions that even if we hadn't tweaked the distribution of critters, it'll be harder for those critters to be in the same exact place given the hotter temperatures or changed rainfall patterns or whatever. So part of that is a sort of ongoing phenomenon, but on top of that is all this stuff that Tom's talking about, which is mixing it up. People actively planting, actively cutting, actively moving, and so it's very tough, right? It's very tough to know what is the target or what is the desirous condition, even if we somehow magically had 100 years of data of this site, which we don't. What's it going to be 50 years from now, right? We want to make these forests robust so that they persist for into the future. But if things are changing, we don't even know where we're changing to. So it makes it a challenging thing to figure out what it was, what it is now, and then what should we make it. Ideally, if we had the power, what should we try to make it in the future?
Yeah, we know that this guy, sort of in the early part of the 19th century, 1900s, named George Allen, was responsible for building those canals. And there was a swamp back then, and the swamp didn't initially die. The marsh didn't initially disappear. It hung on. And George Allen mined the the marsh. He cut down the marsh grass and used it as fodder for mules, mule fodder. And he did this for several years, for maybe 10 years, until there was a fire. Apparently the marsh caught on fire. And when what grew back was no longer marsh, that's when the forest started to grow back. And that was probably sometime in the 20s is when the forest started to develop. The forest that you see there today.
So the forest now contains several non-native species that Katie and the nonprofit that our partners have been working to get rid of, and what we and you all will be doing over there is cataloging the sort of abundance of those species. So do you think, Tom, given that this forest as it exists now is a mix of wet and dry species, native and non-native species, and trees that, at least from the last couple hundred years, probably weren't at the specific locations that they are now? Do you think all this effort to get rid of these non-native species is worth it? I mean, as you said, this forest is a closed canopy forest. It provides these ecosystem services. And Katie's been spending lots of money and effort to get rid of these non-native species.
Yeah.
And we go there every year and monitor the extent. I'll show you the data that we've been collecting.
I'm not smart enough to know the answer to that question.
I'll take a stab at it. I'm not smart enough, but so the issue is there's two issues there, right? So John is saying, hey, we have all these things that weren't quote unquote supposed to be there, and generally speaking, I think most of us say, hey, well, first let's step back. So when we say non-native, the current conversation in our country, unfortunately, might characterize those terms for some people. When we say those, all we're talking about is things that used to be here before humans started messing with the system. That would be native to an area. So non-native or alien or exotic, this is in the context of organism distribution. So every once in a while we have conversations like this. Sometimes people get upset that we seem to be implying that things from other places are bad. And we're not saying that, but in the context of ecological functioning, what we're doing is we're homogenizing the earth. We're taking plants like some of these trees you guys will see, which existed in Asia, and they were cool in Asia, and they were doing their due in Asia, and then we're putting them over here. And then we're putting them over there, and over there, and over there. So what we're doing is we're making the area, the planet, less unique in its various spots, and we're making it more even. So it's as if somebody has like a Hawaiian pizza and a pepperoni pizza and a veggie pizza, and those are cool. And then somebody says, "Hey, let's throw all the pepperoni and the veggie and the ham and everything all in one." And leave it aside if you're vegan or whatever the hell. But right? And then maybe that tastes good. I mean, that's a cool pizza. But now everybody is eating the same pizza, right? So it's cool that we have these plants in Asia. I would say it's also important that we have these cool plants in Louisiana, for example. And so by introducing these things from elsewhere, that changes the value. But the other, so one, I would say inherently most of us would start from the starting point of saying the native is good, the non-native, the invading, the exotic critters are bad, and that's why we try to get rid of them. But in a changing world, maybe those introduced things might have some benefit. They might be more adapted to, say, wind or whatever, different hydrological conditions, and that's what the new hydrological conditions are. So wouldn't it be better to have trees as opposed to no trees? But I would say... But
there are some metrics of like ecosystems that are important, like elasticity of the ecosystem, the diversity of the ecosystem. And it may be that these invaders actually reduce the diversity of our ecosystem.
And that's what I would argue is, at least initially when this whole thing started, so the stuff that you guys will see, tallow, for example, was super abundant early on, such that, and John works on things sometimes called ecosystem engineers, that not only are they abundant, but the very fact that they're present, they change other aspects of energy flows or material. So they make the soil be different. They make the air move differently over the landscape or something like that. And definitely tallow, some of these species have the ability to exclude all these other native stuff. And when we were doing camera trapping years ago, we still do some camera trapping, but people steal our cameras, so we kind of haven't done it too much in the last couple of years. But what we saw is where we didn't have these really dense, intense stands of these non-natives, we had things like armadillos and deer and bunnies and all these critters. Whereas when we had these really intense stands, basically the only thing we consistently saw were snakes and maybe some very small critters like bunnies. So the fact that we had this overdominance, overabundance of these non-natives meant that the ecological functioning of the system was changed. But I think John's question is more like now. Once those, correct me if I'm wrong, but now those things have died back a little bit, so it's not 100% cover of tallow. Should we still be worrying about tallow?
Well, I would say I've never seen, I mean, I've heard, but what I think we're all afraid of is that one day it's just going to be a complete tallow forest. And I don't know if real complete tallow forests exist. I'd love to go somewhere where the supposed
Tallow's
stable
the bad guy,
endpoint,
the non-native one.
we've reached that stable endpoint of where it's, it's now a tallow forest rather than a bottomland hardwood forest.
But so I would argue it's worth. So it seems like hydrologically, one of the things we talked about the ecosystem services of these forests is they act as a speed bump. So when we have the hurricanes come into New Orleans, let's say, they hit a marsh, and that's better than ocean, but it's quote unquote just marsh, right? Which is maybe the grass is as tall as your arm, or maybe as tall as your butt or something, but it's not really big, right? Whereas when we have trees that are 10 meters tall, 20 meters tall, when these winds come, it actually really knocks down a lot of that wind, at least the wind close to the ground. So and these are big honking trees, at least these cypress-dominated things, right? So we have a bunch of these sticks up in the air. If my big chest starts to fall over and I bump into another tree, I'll bump into it and I won't fall over immediately. Whereas the tallow are much more slender; they're more like toothpicks. Whereas the cypress trees are more like big honking elephants. The invaders tend to be more thinner and less robust. So presumably they don't do as, we haven't really fully tested this yet, but in a big honking hurricane, they probably don't provide as much ecosystem services in the context of storm protection. So that's another thing to think about.
I was thinking as you were saying that, like, since the environment has changed so much due to like human activity, the fact that there were like thicker forests near the river and more marshes towards the middle, maybe it won't go back to that like equilibrium, I guess you'd say, the natural like setting. So maybe is there a chance that something like that invasive species might be useful in a certain way, as far as not being able to bring that like native environment back to the way it
Possibly. So something new. You're talking about a new stable state.
Yeah.
Something that wasn't what was before,
Something
but
was
is something
before.
that maybe not be perfect, but it's better than the worst outcome. Possibly. But I'd say another thing, then Lauren should say, another thing that's important here is we're the weirdos from the West Coast that come in and monitor this, right? There's, by and large, nobody else doing this. So it's also cool, I think we'd all agree, that if what we're trying to do with this restoration, restore this place, if it all craps out, in a sense, that's okay. I mean, we don't want it to crap out, but in a sense, that's okay, because we're measuring it. You would think that there'd be all these people in Louisiana that'd be measuring the health of their bottomland hardwood forests because this is their protection from hurricanes. But there's not, right? So even if what we do shows that these restoration efforts and these management efforts didn't reach the goal we're shooting for, in and of itself, the fact that you guys are doing all this measuring and your predecessors have been doing all this time, that's valuable because we're giving to this community the truth, right? Which in today's world seems to sometimes be a precious commodity, right? And so we can actually say at the end, and in fact, it's a little bit easier because we don't live there, right? It's a little bit easier for us to say, hey, this worked or this didn't work, because in a sense of living day to day, we don't have a dog in the fight in that sense, right? So we're a bit more objective, we're a bit more outside. And you can imagine if we did a study on, hey, how healthy is the management practice on CSUCI, and we did the survey, no matter what we find, some people would be kind of like, really? Aren't they just, they're kind of tools of the university or representatives of the university or something? So there's also the whole benefit of just the fact that we're gathering this data. And regardless of if this was the right thing or not, we're learning more what the correct answer is, so that other people, our other friends and colleagues and collaborators across the region, they can take that knowledge and they can decide if what we're doing is perfect. They then have a really good estimate. If they want to do this, it's cost X number of dollars per acre. Or if what we did screwed up, that's cool. What's not cool, we should never allow, is to keep doing the same dumb thing over and over again. We don't know what to do, so let's try this. Aha, that didn't work. That's cool. It is absolutely inexcusable to repeat that same mistake. We don't have that much money. We don't have the time with our planet. So the fact that we're collecting knowledge in and of itself is a valuable helper. Even if this path we're going down, like John is asking about, this path we're going down, maybe it turns out this isn't the best path to be going on, we'll at least know to be able to put up a warning sign for the people after us, hey, don't go down this path, try the other path. And too rarely in a lot of the conservation stuff that we hear about, do people do rigorous assessments like this. And so too often, we repeat the same mistakes and we waste the same time and we burn years of trying something that's not going to achieve a desirous goal. So I would say there's several reasons what we're doing is helpful. Whether this ultimately is the best way, I'm not sure yet. Sorry.
Well, now I have a couple comments. It's been a while, so I've had to reevaluate. But the first thing I wanted to say was that we call it invasive species for a reason. To my knowledge, historically, there have been certain things that we've introduced for the wrong reasons, not necessarily for the effect of the ecosystem, like for just randomly wild pigs on the island. Things that
ornamental because they look pretty or something.
They damage the environment. They damage the soil. That's invasive. Like they're doing something to the system that is not natural, that's not supposed to happen, that it is making it impossible for all the natural things to occur on their own the way they're supposed to. That's what I see when I hear invasive species. I don't think this was, it may not have been supposed to be here, but it's also having an effect on everything else that's supposed to be here. That's why I think invasive is an appropriate term for it. And then the second part was I was thinking about when we talked to the professional in Volcano, I think it was, talking about invasive species, and I think one of the questions we asked was whether or not they're introducing different insects or different plants that maybe counteract that. And I think that while I don't know much about the scientific aspect of it, I think that that is a pretty good approach to it, is to kind of experiment with, which is basically everything I was going to say you already said, but to experiment with what we can introduce and what might maybe counteract those really, really damaging
So biocontrol. One of the terms that is biological control. So we introduce another organism to try to deal with some of the downsides of that organism that's here. Do you want to chime in on the definition of invasive, John?
It's one of those things like, well, I used to say things like American democracy, that like everyone knows what it is, but no one can really define it. Sort of a similar thing, like it's usually applied, so there's introduced, meaning that a species which has evolved in one of the in isolation, evolutionary isolation from other species, typically one of the 5 biogeographic realms, which have been traditionally sort of areas where species evolved together, right? And humans have moved species amongst these biogeographic realms. So there's lots of species that are introduced into North America that didn't evolve here, right? But there's lots of those species that, as far as we can tell, don't really have much of an impact. Like, dandelions are around the world, right? They work around the world originally, but now that they're ubiquitous, right? You see them everywhere here. But in terms of their impact on sort of the ecosystem, it's hard to see what they are. And oftentimes that impact is closely associated with the human impact. So the species that I studied, pampas grass, one of the reasons we only found it where it was most abundant was places where humans had disturbed the ecosystem, right? So they were kind of markers of human disturbance. But in addition to those, there's lots of species that once they've gotten here, they've increased in abundance a great deal, or they've spread a great deal, or they're species like ecosystem engineers that greatly modify the physical environment. So basically act as keystone species, right? So sort of the inverse of getting rid of sea otters on the coast here, right? So I come from Oregon. Beavers are our state mammal. They were introduced to
And your mascot.
and our mascot. And I just bought a piece of art called number 2. Yes. But so beavers were introduced to South America, Argentina, and where they've been building dams like crazy. But there were never beavers in Argentina before. You can imagine something that comes in and takes all the streams that are flowing through Patagonia, right? Now have beavers on them that have turned these streams that are fresh-flowing, fast rivers, right, and streams into these big, still ponds. That's a tremendous change to that ecosystem, right? So there's lots of species like that people usually call invasive, right? But there's it's sort of a fuzzy thing, right? It's sort of one person's, well, this is a big impact, maybe another person's, it's not all that big of an impact, right? So there's no real kind of inherent biological definition. This is an invasive species, right? Like this is a CAM4 plant, right? It's either a CAM4 plant or it's not a CAM4 plant, right? Whereas whether it's invasive species or not an invasive species is a little ambiguous. Even what is introduced versus what is not introduced. Like the dandelion, right? Well, I say it probably wasn't always global, right? But maybe it really was always global. Maybe there was species that were just always evolved, sort of inherently evolved a global distribution. Right?
And just another interesting story about invasive species. I was mentioning that I worked on Laria tridentata, creosote bush. 50,000 years ago, there was no creosote bush in North America. Now it is the dominant organism.
Wait, that's a different class. Different class.
That's a Freudian slip. Organism in the warm deserts, the cold deserts of North America, all the way from California through Arizona into New Mexico, Texas, Chihuahua, Baja California. The dominant organism is Laria tridentata. But it didn't exist here 50,000 years ago. It got here from South America, from the tip of South, from Argentina, in some freak dispersal event. And it marched across the landscape, completely destroying all the natural communities that existed there beforehand. So that is a huge, huge change in what was once these important natural landscapes, and was probably responsible for a bunch of extinctions. Probably even extinctions like the Pleistocene megafauna, like sloths, that existed in the Mojave Desert 10,000 years ago, but died out. Why? Well, we think it's climate change, but let's not forget that creosote bush is a plant that is almost inedible. And it almost completely replaced the natural communities that sloths naturally ate. So,
So yes.
It's a natural invasion.
Totally, right. And we've had Datura is the same way, right? Datura came in. So just a quick note here. You guys are all college students. You guys should think about these things. These are important ideas. In our current climate, some folks would hear part of what John just said, part of what Tom just said, and say, invasive species, it doesn't matter, because there is this natural invasion. That's important for you guys to think about and understand and mull over. In many cases, for the managers, we have the luxury to think about this, you and I. For the managers that need to manage this land today and decide what's going to happen with the rainstorm coming tomorrow or the funding coming next year, there really are downsides to invasive species. And just because sometimes there are these so-called natural invasions doesn't mean the massive boot on the neck of this planet that is humanity is not having downsides. So just because these things have happened in the past and it's hard to nail down some of these things, don't go down the weirdo thinking wall that invasives, well, we just don't know if they're good or bad. Generally speaking, on average, these events cause problems. Generally speaking, these events make our planet less depauperate in terms of diversity, in terms of functioning, less able to withstand change, all this kind of stuff. So important concepts, you guys should debate them. But if you're having Thanksgiving with your uncle, the crazy uncle, maybe don't talk about the invasion of creosote bush, right? Because I'm not trying to disparage your uncle, but maybe he's not going to think about this for a couple days like you guys are, right? He's just going to hear, scientists are stupid, right? Dummies, you don't know what they're talking about. It's all a scam, right?
That's my uncle.
Yes. He's Greek. So, right. So, and then throughout this trip, you guys should be thinking about a lot of stuff. We'll talk about a lot of stuff. You guys see a bunch of fantastic things. And you guys be working on your blogs and stuff, and that's totally cool. You guys say what you want. I'm not telling people to censor yourself. But we do need to think, particularly in this day and age, when we're talking to ourselves, we can maybe have somewhat more sophisticated discussions. When you're talking to folks that maybe, let's say, might be skeptical about certain facts and things, don't censor yourself, but you should think about how you would if you did a blog post on this presentation, you might want to think about how you discussed natural invasions of Laria 50,000 years ago.
Yeah.
Right? Just because increasingly folks that think science and reality and things like that reality is a relative thing, and it's not. There are real downsides of homogenizing the planet, all our plants and animals and pollution and over harvesting and that kind of stuff. So we should have these conversations, but just be careful when we talk to folks that maybe haven't had the luxury that you guys have had of debating all these ideas and holding all these ideas in our heads and stuff.
That's right.
You want to go next?
Even though, just to undermine you completely.
Yeah, undermine me completely. Go ahead.
Imagine that you are tallow, and you're listening to us walking through the forest, telling these people
right. So I'm a tree.
what an invasive species tallow is, and tallow's looking at you saying,
I would show
"Are
my
you
leaves.
fucking insane? Human beings have totally destroyed the planet. Human beings are the invasive species that we have to worry about. And let's get rid of them."
I would say you used to love me, because who named tallow, John?
I know.
But is it Benjamin Franklin?
Yes, Benjamin Franklin, right? Popcorn tree.
I'm not.
I thought that's what it was. Because I thought he was promoting it because of the tallow-like
Yes,
candle.
He did throw it. I'm not sure he named it tallow.
Oh, I thought he was the one that came up with it. Anyway, the point was, Benjamin, so some of our founding fathers liked this invasive plant, right? And so it gets very interesting when we go all right. Are you going to talk, or should we take a break?
Segue, actually.
Okay, let's take a quick segue. Hold on.